Hi. Wait. Okay. I think I'm recording. So, hi, guys. Obviously, I'm not here first period. Um, I just want to explain a few things. Hopefully, you are looking at my screen. And here I have an integral. It's, and this is just very basic. It's read the integral or the definite integral from a to b, notice it's from the bottom to the top, of f of x with respect to x. Sometimes for making it shorter, we just say the integral from a to b of f of x dx. Now, what does this mean? What does a definite integral mean? We saw it at the beginning of the school year, but maybe a refresher would be good. When the integrand, in this case f of x, that's the integrand, is a rate of change, then the definite integral simply represents the total change. What? So in this case, for example, in the integral below, the integrand is g prime of x, which represents the instantaneous rate of change of function g of x. And the integral represents the total change. So the integral from 4 to 10 of g prime of x with respect to x represents the total change in function g from x equals 4 to x equals 10. Okay? Let's see another example. Actually, before we move on, notice that g prime is the rate of change of g. That's why it's the total change in function g. Okay? Let's see another example. Consider the graph below of function v of t. The speed of a vehicle in meters per second at time t seconds since passing the starting point of a straight track. The graph shows function v of t. I'm going to zoom out so that we can see the function. Okay, so there's the function. This is v of t, right? For speed, in this case, speed and velocity are the same because speed is positive and we're in a straight track. So recall that the definite integral is the product of the independent variables, so the product of the horizontal and the dependent variable with the vertical. And that speed is the rate of change of distance. So in this case, the definite integral from 0 to 20 of v of t with respect to t is the area of the triangle here from 0 to 4 plus the area of the rectangle from 4 to 8 plus the area of the trapezoid here from 8 to 16. This is a trapezoid plus the area of the rectangle here, the tall rectangle. And we stop at 20. Basically, we ignore this part because it's after 20. And our integral says only from 0 to 20. Now, I'm going to zoom out a little more. So to calculate the definite integral, the area of the triangle, well, the base is 4, the height is 10, so 1/2 of 4 minus 0, that's the base, 4 times 10. Then the area of the rectangle, the base is 8 minus 4, and the height is 10. We multiply them. Then the area of this trapezoid, the area of the trapezoid is, well, the base is 16 minus 8. And the average height, yeah, it's 15. Yep, I think I made a mistake here. This should be 20. Jeez. So 10 plus 20 divided by 2, that's 15 times 8 is 120. My answer is wrong. It's 120. Yeah, mistakes happen. Plus the area of the rectangle, the base is 20 minus 16, 4 times the height of 20. Okay, and that happens to be 20 plus 40 plus 120 plus 80. The total would be 260, not 240. So, what does it mean? Interpret the meaning of the equation below in the given situation. The integral from 0 to 20 of v of t dt equals 240, or it should be 260. It means from time t equals 0 to time t equals 20 seconds after passing the starting point, the vehicle traveled a total of 260 meters. Why meters? Why meters? Well, it's because of these areas. We're multiplying the base, which is in seconds, times the height, which is in meters per second. So the seconds cancel and we get just meters. All right, next. Let R of t represent the rate of change of a population of a country in thousands of people per year at time t years. So what does this represent? The integral from 2 to 4 of r of t with respect to t. It represents the change in population, the total change in population of that country in thousands of people from the second to the fourth years. From the second to the fourth years. The total change in population. Function b of t gives the temperature in degrees Celsius of a pan of brownies by time t minutes after being put into an oven. What does the equation mean in this context? The definite integral from 0 to 6 of b prime of t with respect to t is 93. Okay, so b prime is the rate of change of b. So this integral means that the temperature of the pan of brownies increased a total of 93 degrees Celsius during the first 6 minutes from 0 to 6 of being in the oven. Okay. This next one, the number of people who have adopted a new fashion trend is increasing at a rate r of t people per month, where t is time in months. What does the integral below represent? From 5 to 6. Integral from 5 to 6 of r of t dt. Well, again, this is a rate. R is a rate. So the integral represents the total change. So it represents the growth in the number of people to adopt the fashion trend during the 6 months. Why the 6 month? Because it's from 5 to 6. So 5 months have already been completed, and this is from like after the fifth one ended to the sixth one. So the 6 month. Finally, a grocery store receives a shipment of bananas. The percent of the shipment that is still suitable for sale is decreasing at a rate of R of t percent of the original shipment per day, where t is in days. At t equals 2, the grocery store found 85% of the shipment to be suitable for sale. What does the equation below mean in this situation? 0.85 plus the definite integral from 2 to 4 of r of t dt is equal to 0.60. Okay, so at time 2 it was 85%. There's 0.85. So this means that after 4 days, 60% of the shipment of bananas was still suitable for sale. And that's it. I hope this helps. Answer the worksheet.